So when you are talking about searching, you are looking for a target data within the list or within the array elements. So when you say searching, you search it from the first position down to the last position until you see the equivalent value of your target data. Okay, so as defined in slide number 2, it is the process of finding the location of a target among a list of objects. So meaning when you are doing searching in programming, you're not actually getting the element itself, but where it is actually located, or where is the possession of that particular target value or target data. So now in data structure, there are two types of basic searching methods for arrays or for lists. So these are the sequential searching and the binary searching. For sequential searching, normally when we are talking about sequential searching, it's either a sorted list or not sorted list. Not sorted meaning it's actually randomly random values that assigned in each position, elements on the position. Okay, so it's either a mixed values. Okay, so let's say for example, I have an array with size 5. So the first position contains 5, the second position is 1, third position is 10, fourth position is 15, and the last position is 0. So if you're going to imagine all those data values, it's not sorted. When you say sorted, it's also a type of list that can be done with sequential search algorithm. So when you say sorted, it's either on descending order or ascending order. So when you say ascending order, it's actually from lowest to highest, and descending order is highest to lowest. Okay. So now, how are we going to apply sequential searching? Okay, so sequential searching is done by finding the target data or the target values from the beginning of the list and then searches it until it finds the data or hits the end of the list. Meaning, for example, if you are finding a value within the list, okay, and when you get your target data from the list, that means your target data is within the list, and it will return the value, which is the location or the index of where we find the target value. Okay, otherwise it will return a value automatically in programming when we are dealing with found and not found. Meaning found means we found the data or we found the target data. Not found means we do not find the target data. So specifically, if we found the data, we can return the exact location where we can find the data. Otherwise, we return a -1 value assigned as we do not actually get or find the data. Okay. Now, if it's an unsorted list, okay, or not sorted list, okay, you are going to start it finding the target data from the first position and check whether that first position, okay, the elements within the first position is equivalent to the target list. If the first position is not equal to the target list, then you increment the position by 1. So your next position is at position 1. So remember that in an array elements, we always start the position at index 0. So after 0, the next position is 1. Now again, if position 1 element is not the same as the target data, then we move to the next position again, and so on and so forth until we see or look or not look for the target data. Okay, so yun yung sequential searching if it's not sorted. But if it's sorted already, let's say for example, sorted, I have a value or elements within the list like 5 for the first position, 10 second position, 15 third position, 20 and 25 for the fourth and fifth position. So for example, your target data is 5. Okay, so when you say 5 and your first position is already 10, and that's already sorted, meaning 5 cannot be found within a list already because on the first position, the first data or the first element is already 10. Okay, so in a sorted list, the search terminates when the target is less than the current element. Meaning if the first position is already greater than the target data, you stop the execution of the loop, all the algorithm of searching, doing sequential searching, because you cannot anymore find the target data because the first position contains higher value than your target data. Okay? So that's the sequential searching. Okay? Now, in sequential searching algorithms, So it needs to tell the calling of algorithm. So first is you need to find the data it was looking for. So meaning you need to get the target value or the target data. And then when you see the target data or when you are looking for the target data, you need to get the index, okay, where the target data is found. Okay. Now, if you are already searching it using sequential algorithm, it needs actually 4 parameters. Even in the other method or in the other algorithm, you need to have these 4 parameters. What are those parameters? Number 1 is the list we are searching for. That's, for example, the array. Okay? And then index to the last element in the list or the size of the array. So if you have the target a list, or I mean, if you have the array, of course, you need to find out how many elements within the list. Okay, so let's say, for example, if that is 10, so your second parameter is equivalent to either 10 or 9 because again, as mentioned a while ago, array starts from the from position 0 down to 9, okay, if it's 10 elements. And then of course, you need to have a variable for your target or target data and as well as the location, the loc, the index or the pos or position where the found element index location is to be stored. Okay, so those are the 4 parameters needs for sequential algorithm. So I'm going to show you an illustration on how we locate data in an ordered list using sequential searching method. Okay, so again, as mentioned a while ago, this is an ordered list. So let's say, for example, I'm looking for 14. So how are we going to deal with searching specifically sequential? So again, we are going to start it with the first possession. Okay, so pos is equals to 0. Okay, then if we're going to have a statement or a testing condition wherein we need to check whether it is true or false. Okay, so let's say, for example, if the target value is equivalent to the first position or the element within the first position within the list. Okay, so let's say, for example, I'm looking for 14. So our target data is 14. Is 14 is equals to 4? If it's no, okay, if it's no, you need to move to the next position so that you can locate whether there's another value or element which is equivalent to your target value. So again, 21 is not your target value, so it needs to move to the next position, which is position 2. And then, if the position or the elements within the position is equivalent to the target data, so it means we stop the execution of the loop. Okay, so meaning when you are talking about searching, you need to apply looping statement algorithm as well. Okay, now here, so increment again the next position by 1, so it becomes position 3. And if you're going to take a look at position 3, the elements of the position the elements in the position 3 is the same value of the target given. So that means we're going to stop the execution of the loop and we need to send already or return already the value where we look or where we search element 14, and that is at position 3.